Hello everyone. Today I will be presenting an analysis of Practicum report entitled Staining Techniques in Protozoa Observation. Thank you for the opportunity to speak today. I'm Siti Nurhayati Nisfatullaili from Universitas Negeri Semarang. This presentation summarizes the result of Practicum where we observed the effects of 5 different staining techniques on protozoan visibility under a light microscope. Protozoa are unicellular eukaryotic organisms that are microscopic in size and often invisible without special treatment. Due to their transparent nature, it is difficult to identify their internal structures such as the nucleus, cytoplasm, or other organelles without the use of staining. Staining is fundamental technique in microbiology used to enhance contrast and help visualize specific cell structure more clearly. Its staining agent interacts differently with cellular components based on chemical affinities. Therefore, selecting the appropriate stain becomes crucial in microscopic observation. In this practicum, our group investigated which staining reagent provide the best visibility for protozoa and whether the fixation process using methanol influence the staining outcome. Understanding this variable is important not only for academic training but also for real-world diagnostic accuracy in parasitology and microbiology. This practicum aimed to achieve three main objectives. First, to practice and apply simple staining technique to protozoan sample. Second, to compare the staining outcome of 5 dyes, Safranin, Hematoxylin, Giemsa, Acetocarmine, and Methylene Blue on various species of protozoan. Third, to observe and identify internal cell structure such as the nucleus, cytoplasm, flagella, kinetoplasm under the microscope, and determine which stain reveal these features most effectively. The laboratory procedure began by preparing slide using albumin layer as an adhesive base. A drop of protozoa culture was placed on each slide. In select sample, fixation was performed by applying methanol for 1 to 2 minutes. After fixation, each slide was stained using one of the 5 dyes. The excess stain was rinsed with distilled water and the slides were dried before microscopic observation. Observations were carried out at 400 times magnification using a light microscope. The protozoan species analyzed include Entamoeba histolytica, Trypanosoma sp, Giardia lamblia, and Euglena antifossa, all collect from specific protozoan culture. It's important to note that not all groups apply fixation, as the protozoa used were already dead. However, this decision influenced the clarity of the staining, particularly for certain days. Our finding revealed clear difference in staining effectiveness. Giemsa produced the strongest contrast, especially in Trypanosoma sp and Euglena antifossa, where the stain made the nucleus bluish purple and the cytoplasm pale pink. Methylene Blue showed the clear internal feature of Giardia lamblia, even without fixation, due to its strong interaction with acidic cellular components. Safranin successfully stained both nuclei and cytoplasm in Trypanosoma sp, producing a vibrant red color. In contrast, Hematoxylin and Acetocarmine performed poorly when no fixation was applied, particularly in Entamoeba histolytica. The nucleus becomes indistinguishable from a cytoplasm, making it difficult to observe clearly. One notable and unexpected result was the appearance of Trypanosoma sp in amoeba culture. Although unusual, this occurrence was most likely due to cross-contamination or residual organism in the culture media, highlighting the importance of laboratory sterilization. Additionally, slides that were not fixed tend to show weaker staining with hematoxylin and acetocarmine, while stain like Giemsa and Safranin still provide strong visibility even without fixation. And below, I attach the result of the practicum work. This practicum demonstrates the staining quality plays a crucial role in visualize protozoan structure under the microscope. Giemsa, Safranin, and Methylene Blue offer the best contrast and clarity, making them suitable choice for routine staining procedure, especially when time or materials for fixation are limited. Hematoxylin and acetocarmine were less effective without fixation, showing the importance of proper preparation when using these dyes. The difference in effectiveness highlight how both the chemical properties of stain and sample treatment, such as fixation, must be considered for accurate observation. Through this experiment, we gain valuable insight into the microscopic analysis of protozoa and the practical significance of staining technique in laboratory diagnostics. I would like to thank our supervising lecturer, the laboratory assistant, and my fellow group member for their cooperation, support, and dedication throughout this practicum. This experience has been essential in developing our practical skills and understanding in microbiology. Thank you for your attention.